Hello everyone, welcome back to Developers and Coders Club of NIT-A. Today we are going to discuss Codeforces round 871's problem statement E, which is the lakes. So in this question, we will be given with a grid of n cross m, uh, and it will contain non-negative integers. And the thing is that we have to find a lake, and the conditions for the lake are that all the elements in the lake should be aij should be greater than 0, means everything should be positive, and there should be a path between all the pairs of cells. So let's consider this case, like in the first test case, 1 2 4 3, these four will be our lake. And why 5 will not be included in this lake? Because we can't reach 5 by moving left, up, down or right from any other lake's cell. So we have to find the biggest size of lake, means biggest volume, and the value of volume will be counted by adding up the depth of cells, which is the value. So how will we solve this question? Let's see. Let's take the third test case as our example. So as you can see, this is the test case where we have to find the deepest volume, means the total volume of the largest lake which we can form. So what we will do is we will use the DFS approach. And how will we solve this? We will iterate from first index of this 2D matrix to the last index, means this. So what we will do, we will come here and we will check if it is not equal to 0, then we will make another matrix. Let's suppose its name is mark. And what we will do is if its value is greater than 0, and mark initially we will mark all the value of this mark 2D matrix equal to 0. And if the mark value is 0 and our matrix value is greater than 0, then we will mark this. And we will call all the four neighbor cells of this cell. Like in this case, this and this will be our neighbor cell. But as you can see, these two are not valid because they are not inside the matrix. Only these two we can call. So we will check if whatever cell is feasible, we will call on it, and we will recursively call this. And there also we will mark this one and mark this one, and similarly we will call recursively to all the elements which are connected to the previous cell and which have mark value equal to 0 and their own value is equal to 0. So similarly, as we will traverse, so we will cover up all these points because it's a BFS, sorry, DFS. So this will cover all these points, and this will be left. And when we will reach 0, we will not call recursion because it's not feasible, because it should be greater than 0. And similarly, when we will come at 5, we will again call it, and here it will again make it 1 and it will return 5. So there will be a function which will give us all the connected components value, and we will find the maximum value and we will return it. So now let's see how our code looks like. So in our code, there is a function max finder which will find all, which will traverse DFS and will find all the connected cells which have value greater than 0. So first we took input here till here, and then we made a variable answer which we initiated from 0, and then we are iterating from the first index to the last index of 2D matrix. And for each, if our mark matrix is equal to 0 for that index, and if our array matrix which we took as input is not equal to 0, then we are calling that max finder function, and we are saving maximum value of the return of max finder and our previous value of answer, and by this we will achieve the maximum value and which we are printing. Here is the max finder function where we are going left, right, top and bottom of all the uh, all the cells of array matrix, and by this we are returning the max value. Let's run the test case. So it's passed. Thank you for watching. See you in the next video.